In this video, we're going to discuss how to calculate the derivative of an Arccos function. So the derivative of an Arccos function is 1 over the square root of 1 minus x squared, or I should say negative 1 over the square root of 1 minus x squared. And what you'll notice is it's the same as the derivative of an arcsine. It just has a negative sign in front, so it's the negative derivative of an arcsine. So to calculate this, what you're going to be doing is you're going to be writing 1 over the square root of x, or 1 minus x squared, times the derivative of x squared. But perhaps a more intuitive way of looking at it is you're going to go negative 1 over the square root of 1 minus whatever is in this argument, because it might not be x, it could be a, it could be y, it could be y squared. Okay, whatever that is, times the derivative of whatever is in this argument here, whatever this box is. So let's demonstrate that by doing an example then. So let's say you're given a function g at x equals arccos of, we'll say, x to the power of 3. How do we evaluate the derivative of that? So we'll call it g prime at x. Okay, g prime at x. So we'll look up here. So the derivative of that is going to be 1 over, or it's going to be negative 1 over the square root of 1 minus whatever this box is. Okay, and in this case, it's it's x cubed squared. But we're not done yet, because what we're going to do is we're going to multiply it by the derivative of whatever this term is here. So we know from our power rule that the derivative of x cubed is 3 times x to the power of 2. So from here we can simplify our expression, and we can write negative 3x squared over the square root of 1 minus. Now, to simplify this term here, we just multiply the 2 by the 3 in the exponent, which will give us x to the power of 6. And the square root of that. So that would be the answer for the derivative of this function here. Let's do another example. So let's say you're given a function f at x is equal to the arccos of cos x squared. Okay, so we have a slightly more tricky example here. So as you can see, we have a function within a function within a function. So how do we evaluate this derivative? Well, it turns out it's not too hard. All it is just a few more steps, okay? But again, we're still following this exact same format. So what we're doing is we're going to go negative 1 over the square root of 1 minus, okay, whatever this is. What's this term here? Well, as it turns out, this term here is cos x squared. So 1 minus cos x squared, and then we're going to square all that. Now what we have to do is we have to multiply this by the derivative of cos x squared, okay? Because this term here is cos x squared, as you can see from here. So we're going to multiply that. So the derivative of a cos function is a negative sine function. So we're going to multiply this by negative sine x squared times the derivative of whatever's in the in this term here, our chain rule, which is 2x. Okay, and then we can go ahead and simplify this even more. So we'll go here. Now, as you can see, there's two negatives, so they'll cancel out. So what we'll get is, we'll get 2x sine x squared. And it doesn't matter if you put the sine x squared first or the 2x first. It just looks nicer putting the 2x, so that's why I put it in front instead. Times the square root of 1 minus cos, okay, so this squared here, okay, I can put it here, squared x squared. Okay, so this is just another way of writing cos x squared squared. Okay. Now, what we'll notice from this is that this right here, 1 minus cos x squared, that's actually a trigonometric identity. So 1 minus cos x, or cos x whatever squared, is actually equal to sine whatever this is squared. So the way we can write that is, we can write 2x sine x squared. Okay, the numerator doesn't change, but this entire term here in the bottom, okay, that's inside the square root, becomes a sine. So we'll write sine squared of x squared. And there is our final answer. So that's how you get the derivative of an Arccos function.